All right, if we recall from Friday, example 3 here, our first task is to establish what type of function we're looking at in order to establish the type of integration that's required. I can see that it says d theta, which means theta is the variable of concern for me here. And when you're looking at trigonometric stuff, you got your 6 trig integrals. You got sine, cosine, secant squared, cosecant squared, secant tangent, cosecant, cotangent. So as soon as I see secant tangent of the same thing, this is a secant function, right? Or it's secant tangent function, if you will. And the argument is 4 theta. And if you recall with the substitution technique, because it's not just secant tangent of x, it's secant and tangent of 4 theta, I want to transform this into a different integral that's easier. So what's making this ugly is this 4 theta. And if u is equal to 4 theta, then du is going to be the integral, or sorry, the derivative of 4 theta, which is 4, and then we're going to do d theta, so we're doing a differential. And if we start comparing what we have and what we have over there, you'll see that 4 theta is in these problems. So each of these 4 thetas can be changed to u's. We have a d theta, which is right here. We have a 4 that's missing, right? There's no 4 there. So that's a concern. We need that 4 there. And what I told you on Friday was I can put that 4 there because 4 is just a number. So if I have secant of 4 theta, tangent of 4 theta, consistency of colors here, d theta. Right. I can put a 4 right here if I feel like it, but the consequence if I want to put a 4 inside is I have to put a 1/4 outside. And again, numerical fixes are legal whenever you feel like it. You need a number, go ahead and put it there, and you put its reciprocal outside. If this said, let's say there's 8 here, 8 is 4 times 2, keep the 4 in and pull the 2 out. That's allowed too. So just again, any numerical fix is necessary. As long as all the numbers starting from here to here make the same as the original number. So 1/4 times 4 makes the 1 that's originally there, so that's legal. All right? And looking at my problem now, I've got the 1/4 that came outside. I'm going to change all the 4 thetas to u. I'm going to change 4 d theta to du. And I'm going to get secant of u, tangent of u, du. So the whole idea here is to use u-substitution to transform that into a very basic integral problem, one we would have seen on chapter 5.3. If I saw secant u, tangent u, du in 5.3, the answer is secant of u plus c. It's being multiplied by the 4th, of course. And then what's left to do is we get the answer back in terms of theta. So that says secant of u is equal to 4 theta. So the answer I'm going to go with is 1/4 secant of 4 theta plus c. Again, it's an indefinite integral, so I need that plus c. Whether I put the plus c here is being multiplied by a 4th, still plus c. It doesn't matter what c equals, so that's why I continue to call it plus c. I'm not going to count off if you put c over 4 if you felt like it, but you're making life difficult for yourself, in my opinion, so it doesn't matter what this is called. Call it plus j if you want to. Don't call it plus theta. Theta has meaning in this problem, right? But as long as you don't call it theta, you can call it anything you want to. It's fine. And that's the answer. And again, what type of function is it? What's the argument? What's the differential of the argument? Construct a new integral. Solve the simple integral. Substitute back in. That's the process.